Hey, welcome to a new day on Python coding. Yesterday we worked on the getToDo's function. We added a default parameter. A default parameter means that when you call this function, for example, we call it here, down here, then you don't need to provide an argument for that function because you already have a default value for the argument. However, you know that you can always provide a value if you don't want to have that default argument. Then we also learned about docstrings. This here is a docstring, so it's a string with triple quotes, and in docstrings we write documentation for that particular function. So this should be some short text, one or more sentences describing what this function does. This is good because later on when you return to your code as a programmer, you can read and you know exactly what this function does. This is also helpful for other programmers who are not the authors of the code, so they can also understand the code written by other people. So be a good citizen and write docstrings. And now we're ready to develop this program even further. So I'm excited to continue working with you, and I'll see you in the next videos. I don't know if you have noticed it, but recently we have been working more on improving the code base rather than improving the output of the program. So specifically, we used functions, we integrated functions in our code, even though the code was also working without functions. The program was working because it's relatively a small program. But if the program gets bigger, then you really have to use functions to be able to keep your code organized. So whenever you want to create a process, just put it in a function. And in this video we will go and work even further improving our code. So you remember the example of the barista and the coffee. So let's talk about that again. So I have a question for you. When you order the coffee to the barista, where does the barista make the coffee? Does he or she make the coffee in your table, in the table you're sitting, or does the barista have a separate space where they prepare the coffee? And the answer is, of course, they have a separate place for that, otherwise things would get messy. And that's what we want to do here in our code as well. We want to separate the processes in a separate file. So currently we are in main.py, which is this file in here. What I'll do now is I will right click over the project directory, which is the same directory where main.py is located. So I'll right click here and create a new Python file. You can name this file anything you want. I would like to name it just functions. On PyCharm I don't have to supply the .py extension because PyCharm will add it by default. So that is a functions.py file. And I'll just go to my main.py file and just cut these two functions and paste them in functions.py. And I'd like to open this file to the right side so you can see both files. So main.py here, functions.py in here. I'll close all these. Now I get all these red underlined elements, such as the function call here. So it says unresolved reference getToDo's, because this script now doesn't know anymore what getToDo's is. Same for write-toDo's. So they are defined somewhere else and not in this script. We can fix that by saying from functions import get to-dos, comma, write to-dos. And now the red lines are gone. So if I run the script, it will behave exactly the same as it did before. Just show the to-dos and here they are. So why did I place the functions in another file? Well, this is just a common practice. It's a good practice to do because you want to organize the code when it gets bigger. So it's better to have logical parts of the code in separate files so that the code doesn't get extremely long. So in this case, it's logical to put functions, so procedures and processes, in one file and then simply import them in here. And that is the syntax to import elements from another file to another file. Now this syntax will work only when main.py and functions.py are in the same directory. Because they are in the same directory, this file knows where to find these functions. So that is the name I gave to my .py file. So that has to reflect that file. And of course, these also have to reflect the names of the functions in here. So those from and import are keywords, which are part of this syntax. Now, this is not the only way to import functions. Another way is to just say, well, let me comment this. So another way is to say import functions, and then you see that these are again in underlines because these names again are not defined in this script. They are not mentioned anywhere. When we had that line, which is now commented out, so it's not recognized by Python, when we had that line, that meant that these were available, they became available in the script. But now we have to follow a different approach. If you do here import functions, then here you want to say functions dot get to-dos. And I guess now this also becomes a bit familiar, this syntax. It becomes familiar to you. So that's like the same syntax that you use to call methods. For example, userAction.strip, where userAction is a string and strip is the method which removes spaces from this string. The difference here is that this is a string and this is a module. So it is this script, but when you import the script here, then you call it a module. That's the terminology. So in other words, when we are in this main.py script and we import that other script, we refer to that as the module. Same thing like in the coffee example, where the clients could refer to the area where the coffee is made with another name, and the barista itself with their colleagues, they can refer to that place using their own name. So here in this main.py we are in our table and we refer to that functions as the module, where something happens and this script is not interested about what happens there. The script is only interested about getting the output of those procedures, those functions. So we get the output from there by calling that space. So we can get now functions, we can call functions from that space there. So similarly, we want to mention functions.write_to_dos here, functions.get_to_dos in there, wherever you have these break lines. There and here as well. So now we don't have any more red lines. The question is, which way should you use, this or that? And that's a hard question, and it's not always easy to answer. It depends how many functions you have in the module here. So in our case, we only have 2, but if we had more, then you'd have to write all the names of the functions there and so on, divided by commas. So if that was the case, then it would definitely be better to just import the functions module and then just refer to the functions of that module using functions as the first name, separated by a dot. So that would avoid us having to import all the functions one by one. We could forget one of them, or it could become a long list here. So that's why we have this other simpler way to import a module and then refer to them as here. So if you have very few functions like we have here, you could use that, but this is also fine to use. And this can also make the code more readable, because by just looking at this part here, you know that get_to_dos comes from the functions module. So that gives you some extra information. Whereas if you had only that without the comment, so you'd have something like that. In that case, it's not easy to tell if get_to_dos was defined in this script or in another script. Of course, you can look at the script and see if get_to_dos is there, but it's easy to just tell immediately if this is from this script or from another script. So that's why I would suggest to use this syntax. Lastly, it could happen that you may have more and more files, and in that case you may want to create a directory. Let's call this modules. So this directory, which is in the same directory with main.py. Now if I drag functions.py and drop it in modules, PyCharm will ask me if I want to refactor, so I refactor here. In that case, PyCharm changed this from import functions to from modules import functions. So this is the new syntax now. And so as you see, modules reflects the name of the directory here, and functions reflects the name of the module. So if you ever have directories where you place files, then you want to follow this syntax. Points to the directory name and then to the module. In our case, this is not necessary, so I'll drag this back to the main directory, and this will be used as just functions. So that's about creating modules and importing them. So this is both a script, as I mentioned, from its own perspective. This is a script. From the perspective of the other file where this is important, this functions is a module. So I hope that makes sense. We will run a few experiments in the next video to understand some things better, so I'll see you there. This lecture is one of the most important lectures of the entire course, so don't miss it. If you are able to understand what I'm talking about in this lecture, I'm pretty sure you will succeed with Python. So I'm going to talk about the anatomy of the Python programming language. Part of this video will be a summary of what you have learned so far. So I'll be going over the concepts you have learned and review them and explain them from another perspective so that you can see things from a different angle. Let's start. The first thing I want you to understand is that a program is like a place in the real world. Let's say a cafe. Things happen in a program, things happen in a cafe. In the program, you are the programmer. In the cafe, it's again you who orders a coffee, who orders a salad, etc. For example, to order a coffee in the cafe, you use the order coffee function, so to say. To order a list of to-do items in the program, you use the get to-dos function. You tell the function the to-dos.txt file as a string. In the case of ordering a coffee, you tell this function that you want a coffee. You tell if it's going to be a short coffee or long. And maybe you tell this function how many coffees you want. Let's say you want 2. So far so good, this is clear. Now here is the thing, and this is about understanding what actually types are in Python. So data types, I've been talking about data types, but you can also refer to them as types. This to-dos function gives us a list of to-dos. So first to-do, second to-do item, etc. While this function here gives us a coffee. Maybe in the cafe you also use other functions such as the pay function. As input you give money. As output you get a receipt. Maybe you also use another function such as clean the table. So you ask for a clean service from the waiter, and in this case you don't get an output. Same here, we have this write to do's function. This also doesn't give us an output. As you see, we are not returning anything in here as we do in the get to do's function. So this get to do's functions gives us an instance of a list. Now here's where you should make the distinction. I said an instance of a list, not a list itself. We usually say this gives us a list, but the list itself is an abstract concept. The same is for coffee or receipt. So all these are abstract concepts. The actual objects are this instance that we got here, the receipt, which says probably 10 euros or $10. This coffee is an instance. Also, the coffee could be bitter, could be warmer sometimes, could be hotter other times. So there are different instances of coffee. The concept itself, this one here, is just an abstract in our minds. Same goes for receipt, same goes for list. So saying that I'm drinking a coffee or I'm buying a pen is technically wrong. What we should be saying is I'm drinking an instance of a coffee or I'm buying an instance of a pen. You can say I invented the pen. That could make sense. You invented the pen concept. And then people buy instances of that pen. So these concepts in Python are also called classes. So types or classes. Types or classes are used interchangeably, two terms. So you can say this is a type, but you can also say this is a class. So it is a blueprint, just like coffee is a blueprint in our minds, and we know how to make instances of coffee by having that coffee in our mind, that abstract concept in our minds. So same goes for lists and same goes for strings. Another example, we implemented this parse function. So that is another example of a function in programming. This parse function got a string such as 6 feet 12 inches, and it returned a dictionary instance with keys and values. So dictionaries are also instances of this dictionary class. So just like we have different types of classes in the real world, such as coffee, receipt, we have different types of classes in a program. By the way, this here, when you say coffee or when you say short or when you say to, these are also instances. So coffee, this here is an instance of speech, you can say, or you can say words. So just like we have a string here, a string is also a class, and this is an instance of a string, todos.txt. This is also an instance of a word or a speech, you can say. And the number is also an instance of a word. So you give words to this function, order coffee, and you get an actual cup of coffee, an instance of the coffee class. Now, all these instances, so this coffee or another coffee, they all have their own methods. So you can drink a coffee, you can sweeten it. Receipts also have their own methods. Perhaps later you can get a refund using that receipt. Perhaps you can deduct taxes using that receipt if you are self-employed or so on. And we have the same things for objects in Python in a program. So a list have an append method, have a pop method, etc. Strings also have their own methods. Dictionaries also have their own methods. So the function, for example, if we see in main.py, if we see this getToDo's function, this function, when we call it, gives us the list, and then we store the list in this toDo's variable. Now variables in the real world could be just the plate where you place that instance, that object instance. So the plate where you place that coffee cup, that could be the variable. The receipt can also be placed in a small plate. Sometimes objects are not placed in plates, as you see, for example, add here is not associated with any variable. So variables can be optional. Sometimes you need them, sometimes you don't need them. So once we get that list instance is returned from this function, and then we can use that returned object in other parts of the code. Similarly with this coffee in here. So once this order coffee function gives us the coffee cup, then we can drink it, we can sweeten it by adding sugar to it, and so on. So the order coffee is the process which makes that object instance. Now the big question is, who designs these classes? Who designs a list? Who designs a dictionary? Can you design a new class? So a blueprint. Well, we can ask the same question in the real world. Who designed the coffee? Who designed the receipt? Can you design a coffee or a new object? Can you design something new, some blueprints, which other people can use then to make instances of it? Of course, in the real world you can do it. It's not easy, but you can do it. And the same exact answer is given for the program. So you can actually design new classes and then use those classes to create instances, different instances. But why would you design a class? Well, let's say that you want to create a graphical user interface with buttons and text boxes. So in that case, you first would have to design a class, a blueprint, define the methods in that blueprint, and then use that class to create actual windows. And you do the same for buttons. You would write a class for a button and then have that class create buttons. But there are two things you should know about designing a new class. First is that most of the time these classes have been designed by other programmers, so all you have to do is just use them to create instances. So just like we had the case with lists and dictionaries and strings, these are already designed. We can just create instances of them. However, I'm going to cover how to create classes later in the course, and we're going to go a lot in depth. So basically, you're going to be the god of your programs. You're going to design objects and then you're going to create object instances from your blueprints, from your classes. So those are the two things I wanted to tell you, that most of the time other people have designed these things, classes, and the second was that you're going to learn how to design them in the course later on. Therefore, classes still remain a mystery for now, and that's completely fine. Methods also remain a mystery for you, so you know how function blueprints look like, but you still don't know how class blueprints and method blueprints look like. So far we have used functions as we did here with get to do's parentheses. So that's how you use that function. And then we also saw methods such as the append methods. You use it here, but you still haven't seen how these methods are from the inside, the blueprint of a method. So the key concept to take from this video was the distinction between classes or types, in other words, and the instances that these classes create. If you understand that difference in your mind, then you are in good tracks. So that was about the anatomy of Python. Thanks a lot, and let's do some more videos. See you. Hey, in today's code experiments, you will learn some tricks about modules. That will give you a better understanding of how Python works. The experiment we want to run is pretty straightforward. I want you to go to functions.py, where we have defined our functions. And below the functions, somewhere down here, just print something like hello from functions. So this has to be outside of the function definitions. You see, it's unindented. Then I'd like you to go to main.py, where we import functions, that module, and run main.py. Then in the command line here, in the output, what you'll see is hello from functions. So with this experiment, what I wanted to show you is that when you import a module from another module, and then you run the module where that module is imported, so when you run main.py, this script is executed when that script is imported. So the module is executed at these points in here. To illustrate it with another example, I'll stop this and go back to functions and introduce an error here. Instead of printing out a string, I'll print out something like x. X is not defined, so this will cause an error. So now I want to go back to main.py, run again. And this is what we get. The error first started at this line 2 in main.py. So that is this line in here. So this line actually tries to execute functions.py. So it tries to execute that, and then if we trace the error, it says that in line 16 in file functions.py, line 16 is this one, we have a name error. X is not defined. So why did I introduce this error? Well, that was another way to demonstrate that when an import operation happens, it executes functions.py or wherever file you are importing. This is important to know because sometimes you may want that certain code is only executed, for example, hello, you might want that this code is only executed when this script is executed directly, as in run functions. So we get hello here, right? And so maybe you don't want to execute that hello when you run main.py, but still you get that executed. So how do you avoid executing that line when you import? There is a way to do that actually, and that is to put this line into a conditional block. But first of all, why would you want to execute this only when you import that function? Well, maybe you just want to print out get to do's, right? You want to test the function output, so you get that, but you don't want to see that when you run main. But again, main.py will also return that output of the function call get to do's. So we only want to see that when we execute this code directly. Maybe we are testing these functions out, so we just want to work on this functions.py. So the solution, as I told you, is to have an if conditional block. And you say if underscore underscore name underscore underscore is equal, so double assignment operator, is equal to quotes, open and close, underscore underscore main underscore underscore, and then you put here a colon, and then these should be indented under that. Let me make a break line. So that's the if conditional. Now if I run the script functions.py, again I get that executed, and that as well, as you see the output in here and there. But if I execute main.py now, you see that these two lines were not executed. We don't have that code in here. These are executed, so the functions are defined when we import functions, and these functions definitions are available here. So everything that is outside that if conditional, such as this print function, is executed. If I execute main.py, we'll see that we get that output because it's outside of that if conditional block. Now, what is this if conditional block? What does it do actually? Well, we have a variable here. This is a variable, but it is a variable which is defined hiddenly by Python, and its value, and I'll show you what value this name variable has. So let me print that here. So print name, and I'll execute this script functions.py, and that is the value of name. This is a string. So if you check the type of the value of the variable name, you'll see that it's a string, and its value is main. So that is a string, but its value is main only when we execute functions.py directly, run functions. If you execute main.py, you'll see that the value of name is functions. So we get that printed out from that line. So to sum it up, when you run main.py and main.py runs functions.py through that import statement, then the value of name is the name of that file, functions in this case. But when you run functions.py directly, the value of that variable is underscore underscore main underscore underscore, and that allows us to have this condition here. So if name is equal to that string main, that means somebody is running this script directly, and that somebody, which is us, that somebody wants these lines to be executed. Otherwise, if I'm being imported, the file says, then I will not execute this because my name is not main, is something else. So that is the distinction we can make to control what we execute when the file is run directly and what we execute when the file is run indirectly through this import statement. This can have practical uses in certain scenarios, especially when you build web applications. So in that case, you might want to use that to have different outputs when you test the code and so on. So that's something you should know, and I hope it makes sense. You'll see this if name is equal to main in other people's code, and this is actually one of the most asked questions on the internet about Python. People ask, what is if name is equal to main? I hope this makes sense to you and you don't have the same question later on. Thanks a lot, see you later. Hey, in today's bonus example, I want to work on yesterday's bonus example where we built this script. If you don't have this, you can find it attached in the lecture resources in this lecture for your convenience. The script we developed yesterday in bonus examples, so what it does is it asks the user to enter feet and inches such as 3, 12, and then it replies with this message, converting those feet and inches to meters, and then it also says if that kid can use the slide or not, depending on how tall that kid is. So if it's below 1 meter, that kid cannot use the slide, otherwise they can use it, as it is the case here, 1.2 meters. Now, we want to improve this script today by splitting it across different files and then importing those files in the main file. So how would we do this? Well, you probably know that we normally take the functions and put them in separate files. So we have a parse function which parses the string that the user enters in the command line, and it returns a dictionary. And then we have this convert function which gets feet and inches as numbers, and it converts them to meters. What I'll do now is I will consider that this program may become bigger in the future. So I would go and right click on bonus. This is a folder where bonus 14 is. So bonus 14 is an empty file. And in bonus 14, I'm going to place all the code of bonus 13. So copy it and paste it here. And then I'm going to put this function into a separate file. You can do that manually by creating a file inside bonus. So bonus is the folder which contains bonus 14. So in the same folder you want to manually create a new file, or you can use the PyCharm refactoring feature to create that file automatically. For that, you need to select the function, the entire function, and right click and go to refactor, and then you will want to go to move. So you want to move that function to another file. So you want to move it from bonus 14, the current file, to another file. So let's say this is going to be parsers. You can just say parsers, or you can say parsers 14, wherever you prefer. I'll just keep it parsers14.py and press on refactor. This is what happened now. One is that the function parser disappeared from bonus 14. Second is that this line was added by PyCharm. This is saying from bonus.parsers14 import parse. Parse was the name of the function. Bonus is the name of this folder. And parsers14 is the file that was created by PyCharm. So parsers14 is this file. And this file contains the definition of the parse function. So this is an automatic process that PyCharm offers, but you can of course do that manually as I was explaining you. Right click, create the file, put the function in there, and then import parse from here. Now the way to import parse is, there are two ways actually. So this is one way, from bonus.parsers14 import parse, but you can also say just from parsers14 import parse. This would also work. This works because parsers14 and bonus14 are in the same directory, so this works. But this also works because bonus is located in the project directory, in the PyCharm project directory, and that directory is also included in the namespace, so both versions are fine to use. Let's try the same with the convert function. I'm going to right click over convert, go to refactor, go again to move. This time we want to give this another name, so converters maybe. 14, press on refactor, and again the convert function was moved out of here. This line was added and a converters 14.py file was generated with a definition of convert inside. So that is our front end. Now we get those functions, so we have them here, and we ask the user to enter feet and inches. We create this variable parse equal to parse feet inches. So you see that parse is directly referred to as opposed to being parsers 14. This would also work, but you'd have to do import parsers 14, which is yet another way of importing. So feel free to use any of them. I'll just keep it as it is. So parse, and then we got the results. We print out that string. We check if the result is less than 1, and we print that string. Otherwise, we print that other string. So if I run this, it's going to work just fine. Right, so that was about this video. I used 2 modules this time. You could also use one single module and put both the convert and the parse function in one single file. Why did I use 2 files? Well, because I think these functions are a bit different from each other. So one is for parsing, another is for converting. So I foresee that in the future I'll have more parsing functions, and that will allow me to extend the program easier, the app easier. So later I can just add more parse functions here. Maybe I want to parse different metric units, so I can add those functions in here. Although it is debatable whether it is a good idea to put both convert and parse in one single file. So both ways are fine. Don't overthink about that. And that was about this video. Thanks a lot. See you later. Hi and welcome to today's programming tool. Today I'm very excited to introduce you to a new skill. This is a must-have skill for any programmer, and this skill is the skill of controlling the versions of your programs. In other words, version control. So version control is a practice that allows you to track changes in your code and manage those changes. So let me explain what I'm talking about with an example. This is the state of our code at the moment, but let's suppose that we have an issue with the edit case. We realize that about 5 days ago we made a change which caused the issue we have now. So what we want to do is we want to go back to the state of the code as it was 5 days ago. You cannot do that with undo because you have saved the code already, you have closed PyCharm, you have reopened it again. So undoing the changes is not an option. All you're left with is your memory. You'll try to remember what you did change back then and then try to rewrite the code as it was. And that's not the best solution. That's why we have version control systems. So we have version control and version control systems. Version control systems are software which we will install on our computer. You will install it on your computer as well. And that system allows you to control the versions of your programs, of your Python programs. Practically, in this case, if we had used a version control system with our project here, we would be able to easily go back and see the code as it was 5 days ago, and then we can reuse that version of the code. Or just pull up certain changes from that code. We can compare that code with our code, as so we have control over the versions of our programs. So as I mentioned, to control the version of your program, you need to use a version control system, which is a software you install. So now I'll mention the main version control systems which can be used, and we'll have to pick one of them. The first one is Git. And Git is also the most popular version control system, and that's the one we will use. But just for knowledge, I'll also mention the other systems as well. We have Apache Subversion, Bazaar, and Mercurial, to mention just a few of them. Of course, there are slight changes between those, but the most popular one and the best one is also Git. So we'll be using Git, and I will take you through using Git in the next day, so tomorrow, in the programming tool of tomorrow. Today I just want to make you familiar, to make you understand what version control is. So tomorrow we will install Git and we will connect it with our project so that we can keep track of our changes, so we can control the version. But before we go to tomorrow's video, I want to show you a glimpse of version control. So this is one of my personal projects. This is a project, a Python-based project, which constructs a web app, and it's based in the Django framework. So this is the Python code base, and if you go to this button here, of course you don't have this because you have not enabled Git yet, but I have enabled Git in this project. So if I go to that button, I'll have access to all the changes I've made across different days. So for example, if I want to see how my code was at this change here, when I added an exercise and I recorded that change in here, so I can just right click here and then I can compare that file with the local file. So then I'll see here the file as it was back then, and then here on the right I have the current view of the file, how the file is now and how the file was back then when I made that change. So changes are highlighted, as you can see here, and so on. So I have recorded different changes in here. I can click any of them, and here on the right I can see the files that were changed that day, and so on. So that's how Git works in a nutshell. I'll take you through how to make these changes, how to record the changes, how to see the changes, so don't worry about that. This was just to show you Git in a nutshell. Now, this was Git, so the software we installed to help us see these changes in our program. But there's also GitHub. Maybe you have heard of it. GitHub is a software hosting platform. So all these folders that you see here and all the files inside them, for example views.py inside blog, this file is also in here in my project here, Python how. So that is the file. So all these files are uploaded to GitHub. So why would you want to upload your program files to GitHub? Well, that's for several reasons. First, you can use GitHub as a backup system, so it's cloud-based. If you lose access to your files, to your hard drive, you lose your computer, etc., then you have the files on GitHub. And I'll show you how to synchronize your files so they are always up to date with the GitHub platform. So backups is one reason. Other reasons are you may want to share your code with other people. So you may want to create a portfolio for potential employers to see your code or clients. And GitHub can also be used when you want someone to collaborate with your project. So both you and your collaborator can make changes on your own computers, and you can upload the changes to GitHub, and everything there is tracked. So everything is synchronized with the changes you have on Git. So Git and GitHub are synchronized with each other. Git is local and GitHub is cloud-based to back up your code and to be able to share your code with other people. Another role of GitHub is that, for example, in my case, it allows me to upload the code to the web server. So that's a product of that code that you see here. So this is a web app I've built in Python, and this web app has to be run in some remote servers. So that means I have to upload all this code to that remote server, and GitHub serves as an intermediary. So I upload my code to GitHub, and then I get the code from GitHub to the server. So that was a lecture on version control systems, Git and GitHub. So as a summary, version control is the practice of recording the changes you do on your programs, and the way to record your changes is to install a software, which I'll cover later. So the software itself is the version control system. And then you have extras, which is this cloud-based software hosting solution, so such as GitHub, where you can upload your code to have a backup, and it also allows you to share your code with others. And that's about this video. Tomorrow I'll take you through installing and using Git step by step so you can use it on your computer. So I'll see you tomorrow. See you.